When bad things happen, good institutions learn and share, just like I'm about to do right now. It took me 7 years, but I got to it, which is what we're supposed to do. Engineers should not be rushed, and communication should, if it's difficult, just don't give up. So we don't want to have a fire. We had experienced a fire at Texas A&M. This was at the Mechanical Engineering Building, 2018. And then the rumors went around very, very quickly. There was a fire that we lost the whole prototyping labs, one of the labs in mechanical engineering, while I'm working at engineering technology and industrial distribution. And the university published a very brief announcement, followed by some number of months later, a updated policy, or basically something now is not going to be allowed, something is recommended. And I remember, so basically the rumor said that a 3D printer had caused the fire. Another person I talked to said they had the same printer as myself. And by the way, I'm still using those printers, the ones that I purchased for Scuttle, these Creator Pros. They're excellent, by the way. This was the printer involved, and this was only through hearsay, and we were using the same ones at my department in ETID. So as a staff member, I was very curious, and as an operator of printers, I wanted to know what is going on here. We should learn if it was in fact related to a 3D printer. What is the root cause? Well, naturally, they might not know the root cause right away, but that means we ought to do an investigation so that when we discover the technical source of the issue, then we can disseminate the information to avoid that problem the next time. And that means when I read the memo that says what could cause a fire with the 3D printer, then that should equip me with the information to enhance our policies, make sure we do things technically the best way so that we don't also wind up with a fire. But we don't limit our new capabilities, we don't throw away printers, we don't cost more money for the organization or the students, and prohibit more more progress. Over the following years, I continued to do my maintenance on the printers. I've replaced various components. I installed lights in there. And one of the parts you may need to replace after a couple of years is the heating bed. It could possibly warp or other things. And I noticed that this plug was difficult to remove. It was a little bit stuck. And when I removed it, I saw that there was kind of like this left-hand terminal. Please focus. Kind of like the left-hand one, the right-hand one was, it had accumulated some, it was less shiny, accumulated some corrosion. And what can happen is when the corrosion appears, then that connector loses a little bit of its contact area. The resistance can go up, and that can create more heat. That will enhance the corrosion. So this is a compounding process, but you have a lot of time because it takes a lot of time for such a small issue to build itself up. But the time that you have trouble with this connector, or it's looking less than new when you replace it, is a time for you to notice to be asking, why is it less than shiny and new if this is the first time I'm placing it on here? And what countermeasure do I need to implement? Let's rebuild the problem and consider what conditions can cause a problem. So what's the behavior of the printer at the time that this could become a catastrophic failure? So we have heat building up and intermittent contact of the heater cables with the heater. Well, the temperature sensor connects to this terminal, this connector, and it is not the first thing to fail. The thing to fail is this plug, because this is the one that has a lot of current going through it. And also, my impression, just looking at this, is that that's a pretty small contact. It's the minimal connector for actually driving the amount of current you need for heat. And I don't know, I didn't check how much current is going through there, but it's 24 volts. So they've gone up above the potential 12 volts to reduce the amount of current that's needed and still achieve the power that you need. You can see some corrosion here on that surface as well, on the solder joint thing. And this was not that bad, but already apparent long before today. So it's a problem that very gradually builds up. To me, that says, is there something wrong with the circuit? No, it's just that this will happen if you have heat for a long, long time. The humidity in the room and other factors can cause, if it's very hot right here, that's when you can start to get things really degrading. So today, I was running a preheat and it was taking much longer than expected. That's a time for you to ask what's going on and come look a little bit closer. What was going on was it indicated the heater, the hot plate was 30 something Celsius, very near to room temperature, even though it was heating for 10 minutes. And so I went to touch it. Is that in fact near room temperature? Yes, it was. But the heater indicated it was on according to the display right there. Right, so if the display says it's on, then it's going to be sending the voltage on to this connector, and it is simply not heating up. So in this situation, the firmware will not cause it to time out because it thinks it's just taking a long time to heat. There probably isn't a software line of code to handle what if it takes a very long time to heat up. Like there is on the preheat setting, if I'm just preheating, then it's going to time out after 10 minutes or something. Okay, so temperature sensor says I'm low. The temperature controller says we need it high. And so the controller then says continue trying to heat. And then I saw the indicator light, which indicates whether the heater is on or not. Now this one is not red. It was blinking a little bit yesterday when I wasn't expecting it, and now it's not on. So that means we completely lost voltage on that pin, meaning we have these pins are equal voltage. The board is not broken, it's still working, but we just simply did not have contact anymore on this pin. Yet the voltage was there, and so intermittently some amount of current may try to get past the corrosion, but it's going to be a hot connector. It's going to be a hot interface because we have a high resistance. I remember asking several different parties until finally I could talk to someone that knew a little bit of details, or at least so what did they do? What did they change after this fire situation in the new lab or whatever? And someone told me that they had the printer sitting on top of a surface that was flammable, like wood or I'm not sure what type of table, but the best takeaway that I could get is that, well, printers are a fire hazard, and so we need to make sure that they're not going to have a fire spreading. If there are sparks or something, some heat source on the printer, it will not spread if it's not sitting on wood. And so either that department or another department implemented all of the printers have to be away from a flammable source. But that is just accepting that printers are fire sources. That is not addressing the root cause. And when you don't address the root cause, you have no idea whether your new countermeasure will be helpful or not. So during my search for information and talking to people, I remember getting the sense that, first of all, nobody in general had information, that's for sure. And then a few people that were staff, students did not. Staff, it was hard to find the person with information, and I was getting the feeling that don't be nosy, don't be that's none of your business. Stay in your place. Your job isn't in mechanical engineering. That's their thing. Or getting the sense that I had to take time away from my job, the feeling of guilt that if I want to go get information for this, that is literally to come back and use in my printing spaces that I oversee. If you want to actually have the true, real details, that's not it's not relevant for you to want to do that, that is basically. I basically accepted that. That means I was surrounded by a culture that was not a culture of sharing information. And at one point or another, I leveled up and I grew and I understood, well, if Texas A&M publishes a bunch of information about this fire, it looks bad. People could misinterpret it. Or it's just not going to be... that information won't necessarily be handled well by everybody. That is a culture that is completely incorrect. We need to share our lessons so that we prevent failures in the future. We need to encourage people whenever they are on the search for information. We should be helping them, and we should also ask questions. And anyone that I spoke to, we spent so much time between all these small conversations. Whenever I bumped into another person that had worked in that department, wondering about answers, all that time was wasted, and instead that time should be allocated. And I should have been, so if you put me in the top, 5 or 10 people in the university that works with 3D printing and understands the machines, I should have been invited to take time together with the team that's either reviewing the information, trying to understand. It would not make sense to tell a staff member who works on the same equipment that he's not doing his role trying to gather information about a problem that occurred in the same type of scenario. So this ought to be corrected, actually. It may look bad if a university publishes information and technical details about the fire that took place, but it looks much, much worse when the staff member has to go out to the public 7 years later and says, this has been a problem this whole time. We can't even learn from each other's mistakes. Now, my role is to run the 3D printers, support students in learning, do the very best job of managing that laboratory in that place at that time, and keep people safe. And so on the day that I have a feeling that I should I should know more about this, then that is part of my job. Okay, and then but it's also not my job to go searching for the information. I should simply be able to ask my supervisor, can you provide me with this information? And he should go out of his way to reach out and connect and find the information that I need and provide that to me. Because my role is supporting the students and my supervisor's role is to support me. And so if I need something that my supervisor doesn't have, then it goes up the ladder and his supervisor should be asking for this information. And that was not a scenario that I could produce. And that's why we're talking in the public now. So the root cause for that fire issue very likely resides in the electrical connections that are easily updated, repaired, or cleaned, or maintained. And if we do not perform the engineering root cause analysis, if the culture only supports a countermeasure without the root cause, the engineering root cause, that's when all of the updates are made to either raise the cost of the labs, get more expensive printers, get more kinds of insurance, or buy more tables. Basically, without the root cause, you need to assume that your 3D printer is a fire-breathing machine and spend however much it costs to overcome that problem. And that's very expensive. So that is the attitude of money solves problems rather than engineers solve problems. So what happens in the long term? As of today, 2025, our university has fewer 3D printing labs. 3D printing spaces have been consolidated more. The 3D printers are more expensive and further from familiar to students who may have 3D printers at home. They require staff with more number of hours of oversight per printer than before. So we have raised the cost and reduced the productivity, and that is all a result of a culture that treats money as a solution to problems, not engineering. And I would love to see a culture where the engineers, they really do want to solve the problems and they have the skill set to do it. So we're going to support them. We're going to give them the resources so that they can, to enable them to solve problems. This is how we're supposed to be running these institutions. Okay, so if you're a student or a prospective student, then when you go to tour a college campus, this is the question you need to ask. Have you had any failures take place in the technical environment here? And the answer would be yes. If it's no, that's a lie. And then after they say yes, then you have to ask, please show me the report of the lessons learned, the technical report that helped you improve after that failure in this technical environment. And then you will get a report to see how does that university handle improvements. If the reports date back many, many years and they continue up until the modern day, then you have found a good institution to do your technical learning. That's something I wish I would have done on my way into college and into grad school and so forth. Okay, when you're thinking about a particular failure mode, then this is my recommendation. First, we're watching with any machine that we're using, and if the behavior of the machine changes, if there's something strange, but it's not a total failure, then you have to stop your productivity and look into it. And that means the culture of wherever you work must prioritize investigating technical things before high productivity and rushing and getting things out the door. Then item 2, it's to, if you've heard rumors of a type of failure that may be of concern to you, then simply generate a plan, regardless of your countermeasures, generate a plan for what you will do if that failure does take place. So like if the printer itself causes a fire, yeah, it's sitting on wood, a wooden shelf, of course. I cannot, well, that's not the point. The point is there's a plan. So if I'm present, then here we are. We have a fire blanket nearby. And so we can constrain a fire if we're here and that takes place. And the third one is maintain the system. Any interruptions such as this having to stop and fix something small is another opportunity for you to open up that manual, which is why I'm collecting the important manuals all for machines using QR codes to make it more convenient so that when we have a small impulse to do maintenance, then it's not a huge burden to find the manual and go through it, just skim through and see anything we've forgotten from the day back when we set it up. And then regarding number 2, you may not know which failures to look out for, and this is why communication trumps everything. Communicating with other people that have machines like yours, people that are doing work like yours. So the mechanical engineering team may think, well, we're not doing the same thing as you over in engineering technology, but they are using the similar processes, similar methods, and even though we're not serving the exact same people, the ongoing collaboration should be taking place so that expertise can be shared back and forth ongoing. And when you offer, especially your humble failures, and I say, well, I don't know how I'm going to change out this and make an improvement here. When you tell about the situations where you don't know what to do, that, my friend, is when people will actually listen, actually be extra helpful, and they probably won't make fun of you mostly. So this reminds me now, about 2 years back, another gentleman who's got a YouTube channel and does robotics things, he was communicating with me. It was one-on-one. And he disclosed about a fire that took place in his apartment that he would never ever share with his YouTubers because that's just kind of embarrassing. But the concern is legit. And we have many people with some technical expertise, but maybe not so much expertise that they can understand the mechanism that caused the problem. And his story was something like throwing a blanket on this thing and dangling something out the window so that the smoke didn't fill the apartment, so that the alarm didn't go off, because then you'd have... okay, maybe we have a tendency to cover up our mistakes, but find the time when you build up the boldness and the fearlessness to share your stories with someone, because that person will remember. And when they encounter a solution to your issue, they'll come back to you and they will share improvements. And they will also share their similar failures that maybe you overestimated, and maybe you thought everyone has a solution except for you, and they don't. They're encountering the same issues. Okay, so here's the most relevant news article that I could find. This was from back November 2018. And so the mechanical engineering building is the Kane building. Yes, the whole lab apparently did burn down, but no one ever got any photos or explanation of the actual details as far as people like me within the university. So the root cause, all we ever understood was the same information that was public, and that is something about a 3D printer may have caused the fire. Okay, so normally I would not share my issues from the university in the public space. But after giving 7 years, no one has helped me to collect the information, the technical information inside of the university to learn from that big problem of the fire in the engineering building. And I have not been provided any resources or support to do the right thing, and that is to gather the information, to learn from the problem, and to communicate among each other what information is relevant to make an improvement. So this is something that, well, actually the information should come to me, and the information should be spread in between the technical staff at the university, and that did not happen. So doing the right thing means I've got to keep on trying. Now, moving this conversation out into the public space is the step after taking many other steps to try to solve that problem, and it's the right thing to do at this stage. So what I would really love is for the university, if anyone works there, then the leadership at the university who sees this video can provide back to me, here's the countermeasures, here's the lessons learned, and here's everything you need to make the improvements that we should be making. That information should actually flow easily to me and automatically. Then I almost chose not to make this video and not to share in the public. But what is the reason for not doing that? It's a fear. I'd be afraid that somebody wouldn't like that. And we have a brand new, marvelous thing that came from our leadership somewhere in this university. And that is that we have a new slogan. It is fearless on every front. That means I cannot factor fear into my situation of trying to do the best thing. The university will uphold me doing the right thing despite the fear. And this alignment with our core values means every single person in every different situation, while they're trying to do the right thing, they also can be fearless and remain aligned with Texas A&M's slogan, our principles. So yeah, I think that's a marvelous thing to add to the university. And I think that for the engineers, we just need to understand what that means. If you're afraid that somebody will not like what you're doing, but you're doing the right thing, then recognize, connect that fearless on every front. It's not just a slogan. It's very, very powerful. Hope you guys have a great day. Hope if somebody has a really good solution to cleaning this up and then improving it, certainly I can clean it up. Certainly I can resolder a new kind of connector on here, but I'm not sure which one I will do. Maybe someone has already a documented, really nice way to do this. So I'd be happy to if you provide that in the comments. Thanks, everyone. Have a great day.